So we've just finished commissioning a GivEnergy system with a Gen 2 9.5 kilowatt hour battery. This is an AC coupled system with a 3 kilowatt inverter on the G98. So you know it's powerful enough to charge this battery within a decent amount of time. And also we've got an EPS which is a double socket, and it gives you power via normal grid supply, and also via the battery in case of a grid failure. So this is pretty much like a finished product. We need to stick a couple of labels on. As I mentioned, this is an AC coupled system, which means it's a battery only option, which is going to charge and discharge the battery via this AC inverter. This particular house, they're really tall trees with a lot of shading, so the customer, it's not really viable to have solar panels installed, so it's only going to be the battery option on its own, which he will use to charge at a cheap night rate, cheap tariff. I believe he's at Octopus with Octopus Energy, and the rate are about 10 to 12p per kilowatt hour. So it's a very good option to have. So we're just going to do a demonstration on the EPS backup power. So this is the current voltage. It usually varies about 239 to 240, and we're going to now turn the power off to the whole property and watch that socket remaining live via this 9.5 kilowatt battery. So I've just turned the whole power off to the house, and as you can see, the power went off, and within seconds it came back on. So now there's literally no power to the property. We've turned all the power off, but you can see the socket remains live. So now we're going to do an earth loop impedance test, just to see how good our earth rod connection is. So I'm going to put that on a 3-wire no trip and press test, and you're going to see our reading is 1.18, which isn't too bad.